Okay, once again, I welcome you to the lecture series of electric power quality. So this power quality issues we are discussing, so many power quality issues till now is nothing but the long duration voltage variations, short duration voltage variations, under such transients and oscillations and so harmonics and interharmonics and so many things we are already discussing. So in this third chapter, we are in depth discussing about the voltage regulation. This is also one of the power quality issues. This is nothing but what is that voltage regulation? What is that meaning of voltage regulation? When there is a difference, what is the difference? There is a voltage difference in between the in between the primary and the secondary. Okay, we can treat it as a simply of voltage regulation is nothing but Vs minus Vr difference. That measure of difference in between Vs minus Vr, we can call it as the voltage regulation simply. Voltage regulation. How this voltage regulation is depends on which factors? Tell me. This voltage regulation is depends on which factors? Tell me. Now see this one graph. You can go to visualize once again the voltage regulations and some problems. Now see this. There is some Vs ascending in voltage. This is Z. This is load. We can treat it as a load. So this is the terminal voltage or receiving voltage Vr. This Z is nothing but Z is equal to here. The Z is equal to R plus JXL or XR plus JXL or XC water. That depends on the this load. So this Z we can treat it as a transmission or distribution or distribution impedance. Remember this impedance. So this difference is caused because of this Z. Vs is not equal to Vr because of this Z. So that gap is maintained. Obviously, that gap is maintained because of the Z impedances. So how this? You know that someone asked that if this Z is fixed, then why can't we reduce the loss by means of using some another additional equipments in the load side? Okay, is nothing but some power quality improvement equipments. Yes, those equipments were used, but remember this value of impedance is fixed when the load when we are considered the a fixed load. But you assume that load is always varying. So at the same time, load is on and off. Okay, that load is of different types again, non-linear. Linear loads, no problem at all. Non-linear type is also there. That load is also the some critical loads is also there. Some emergency loads is also there. Different types of loads. Some induction motor loads or some arc furnaces loads, for example, arc furnaces, etc. Different types of loads we are assuming here. So what will happen whenever you know that Vs is our distribution company or transmission company is trying to maintain or trying to given this Vs or Vr, the terminal voltage is constant voltage, nothing but remember Remember, these distribution companies or transmission companies are trying to give this voltage is constant at the terminal voltage levels or load levels, load side. But the current, this current is entirely depends upon the load. You know that different types of loads will draw the different types of currents. You know that a non-linear will draw the currents is like this. Like this. I just done I just as assumption is done the like this non-linear. So the type of loads is causes the power factor problems is nothing but the some power quality problems in the power system. Okay, now see this we are assuming this voltage regulation is nothing but voltage regulation here, voltage regulation in this case. Now see this voltage regulation Vs minus Vr. You know that someone is asked that percentage of voltage regulation is nothing but Vs minus Vr by Vs into 100 and so on. When compared with the source side, you can treat it as a Vs. When taking it as a receiving side or I mean this load side, we are considered as a Vr, whatever it may be. You get the same answers. No, not an issue. The percentage regulation when compared with the source side, you will get the some answer. Percentage regulation when compared with the load side, you can treat it as some another way. Whatever it may be, this is the difference. So this difference is mainly of Z. How this Z value is changes because of these different types of loads that we are considering. Okay, the different types of loads we are considering. Now see when this loads are when this one is changes is nothing but the total power. I can call it as a power P is equal to I into Z. I can treat it as a P is equal to the I into the Z. So P is equal to the I into Z is nothing but R plus JX. So if this current is changes, what will happen? The resistance plus the current that is changed by the inductance or inductive capacitance or inductive reactance or changes. If this current is changes, is that entire value is changes. So the total the difference in between the Vs minus Vr is also changes because of this current. Okay, if it changes the Z, if Z is changes, Vs minus Vr is changes, that leads to the voltage regulation problem. Not only the flickers or transients or any, so many problems will leads to voltage regulation problems. So entirely depends upon the load side. Most of the problems is depends upon the load side, because the load is every time is varying. When you on the load, when you off the load, when you shut the on the load, what will happen? When you shut on the load, what will happen? Current is increases. Current is increases. What will happen? Voltage is falls. Or we can increase the amount of load. If it operates at the some 5 kilowatt, you can increase it up to the that distribution system to the 6 kilowatt. That will also leads to the, if the current is increases, there is nothing but I is increases, so voltage is decreased. So many factors are there. How much time it will decrease the voltage? How much time it will decrease the voltage? That entirely depends upon the restoration devices or load side devices. Or you can also not to reduces that voltages. So decreasing voltage levels, we are maintaining the such some type of devices. Okay, the devices we can we are using it for the some capacitors. Okay, some filters. Okay, some capacitors, some filters, some reactors. Okay, some compensators, etc. To regulate the voltage. Remember, to regulate this voltage. So many types of devices, sir. Whenever you are using the capacitors, it is not only regulate the voltage, it is also regulate the, or it is also used for the power factor corrections also. But because of use of these capacitors, in the load side, it will also leads to the again some problem, some switching events, nothing but when the capacity is connected to the system or capacity is disconnected to the system, this will leads to the some transients in the system. The transients we can call it as the oscillatory transients. But why you are using these capacitors? To improve the power factor or to improve the voltage regulations. But using of these capacitors is also gives us some problem. This filters LC filter. We are using LC inductor and the capacitor filters to reduce the harmonics in the system. We are using these filters to reduce the harmonics in the system. Are some flickers in the system. Harmonics are some flickers in the system. Now we can use some reactors, some capacitive reactors. Again, capacitive reactors are tap changing transformers, or you can also using the transformers to maintain the constant voltages, constant voltage at which place? At the terminal side, at the load side. Okay, or we can also use the some compensators. Remember this compensator. This compensator in the sense here, electronic is nothing but the power electronic based compensators. Power electronic based compensators. We are using here compensator is nothing but a power electronic. So other than that, this capacitors, filters, tap changing transformers are not the power electronic. But these tap changing transformers are also somehow the automatic tap changing transformers. What is what is this automatic tap changing transformer? So when this controller, when we have some controller is there to control the number of taps. So you know that what is a tap changing transformer? What is a tap changing transformer? You know that tap changing transformers. Okay. What is that tap changing transformers here in this case? What is the tap changing transformers? Tap changing transformers. What are the tap changing transformers is like this. Number of taps they are connected. Okay, the number of taps. Sorry, can again redraw this one. So simply I am drawing second side. Number of taps are there. Number of taps. So these are the some connections. These are the some connections given it to the some lines, some load side are given connected to the load side. Okay, then transform. So these so these are the levels. So first level, second level, third level, fourth level, fifth level, then the sixth level. So depends upon this level how much amount of voltage is injected into the system is changed. If it is connected to the first level, one amount of load is connected. Nothing but voltage is injected into the system. You know that it is of 30. It can supply the power 30 to the 30 to 40% range. It can supply the voltage, better voltage levels up to the 30 to 40% range. Okay, this transformers, this tap changing transformers. So these most of the tap changing transformers are auto transformers. You know that one of the auto transformer is nothing but you can also auto transform. You know that in our laboratory also we are using the auto transformers to start the some indexed motors or some D-volt status or nothing but whatever it may be. You are also using some auto transformers. You can also treat it as a some tap changes. You know that what is the use of the auto transformer? It can varying the voltages. You know that you can vary the varying the voltage levels by changing the some manually changing the some knobs. But we are treated as a automatic. What is the automatic? Now the power electronics are comes into the picture. Power electronic base. So when you consider as automatic, when it is a power electronic base. So this power electronic based devices is nothing but some PI controllers, P controllers, and other controllers. So we'll identify the how much amount of voltage drop in the load side. So depending upon that drop, so these tabs are connected to the first one, second one, or third one, whatever, based on that. Okay, these are the some of the auto transformers. Or you can also maintain the constant power at the terminal voltages, or you can also maintain UPSs, uninterrupted power supplies. Uninterrupted power supply. You know that VS. You have the some additional devices there, UPS, and then one switch is also there. I'm not drawing that that much in depth. So this is the load. So this is the another direction, a switch, as a switch. This is the switch. When in under normal working condition, what will happen? The power is going like this. If there is a fault in the system, so or there is some interruption in this one. So this switch is automatic controllers will identify that. So it can open this way. So this is open, or this is off. So then power is going to this direction. It's nothing but so it can supply the some power to this load. So that's why you can maintain the some uninterrupted power to this load, or you can also treat it as some hybrid. Hybrid means here in this case you can use this some transformer, some ferro resonance transformers. Is nothing but the constant transformers, or 1:2 transformers to maintain the constant voltages levels at the loads. So all these devices, some capacitors will also helpful for maintaining the constant voltages at the load side. Remember, if the load side voltage and the currents are varying every time because of the load changes, you know that we don't know that whether the customer is on the load, or whether the customer is on the load. So only the distribution agency is knowing that. So an industrial load is on the when that industrial load is on. So when that industrial load is off, unfortunately due to some failure of some devices. So on that time, unfortunately, the industry also suddenly shut down. So on that time, we'll treat it as a huge sudden load of the system. That will leads to the voltage increases in the system. Voltage increases. Okay, that is also one of the problem in this case. Okay, so that's why remember every time whenever you want to see the voltage regulations, you want to see this voltage regulation, not only this one, uh, not only this, remember, let's come to this direction, sorry. Okay, not only this devices is nothing but will helpful for regulation. There are so many devices, sir. So many devices. So automatic devices as well as the manual devices are there. Automatic and manual. What is the disadvantage of manual devices? What is the disadvantage? Time taking. When someone is going and uh, on the some devices are for suppose we are using some tap changing transformers. So someone is going to that place and they can change the taps. Where this is whether that is automatic, what will happen? So automatically, so no manual requirement. It can on and off, or it can changes the taps. Those are the some of the better examples. Okay, so now see this in the last class. So we are also discussed about the something about the you can see this last class. You can see this once again. We will get the more clarity. So this is the voltage regulation. One of the devices for regulating voltage is the distributed generation. Distributed generation. Distributed generation. Distributed generation. So in the distributed generation, or you can also call it as a DC. You can treat it as some small generators Small generating plants. Small generating plants are diesel generators, or some idle or whatever it may be. Whenever you are calling the distributed is nothing but those generators are located near to the load centers. So those type of generators we can call it as distributed generators. Now this is one of the case. So to maintain the voltage regulations in the system. What is this? We are using some generator. You know that whenever there is a fault in the system. So this is the tie line. When you are connected this tie line. So what is this tie line? If there is any fault or here in this line or whatever it may be in this line, what will happen? So so using this tie line, you are supplying this some constant voltage or some power to the loads without any interruption. So as I said in the earlier class, so today's technology that will also helpful or that also allowed to add the distribution generations is like a solar and wind also. Solar and wind also. Okay, so you already seen some drawbacks and whatever it may be. So in the last class we are also discussed about the flickers. So we are today also we are continuing this concept flicker. You know that what is a flicker? So any an human eye is able to identify fluctuations or some illuminations in the lamps. You can simply call it as a power flickers. Okay, so that power flickers, that we can call it as a flicker. How that flicker is happened in the system? What is the reasons behind that one? So how to then flickers we can divide into the two categories: some cylindrical flicker and non-cylindrical. Then now this we can see this in 1 second time, in less than 1 second time, 1 second time, less than 1 second time. It's nothing but in the 50 Hz frequency. You can observe that how many flickers we will get this. You can now see this. These are the gaps. These are the voltage changes. Now see this voltage change, voltage change, voltage change, voltage change, voltage change. For 1 second, you will see this in this graph. They can consider up to 0.9993 seconds is nothing but how many voltage dips you will observe. 1, 2, 3, 4, 5 voltage dips you will observe. Okay, so that flickers you can calculate it by using this formula: V maximum minus V minimum by V0. So percentage voltage modulation or operating voltage is equal to the V maximum minus V minimum by V0. Okay, so we can also look at this. What are the sources? Why this flicker is occurred in the system? Why this flickers? What are the sources? One main source, you know that one main source, main important source is an electric arc furnace. An electric arc furnace. So in the last class also we already discussed about that one. What is electric arc furnace? So this electric arc furnace at first results within the 1 to 10 Hz range. So that this will causes the more impact on the system. So 1 to 10 Hz range is nothing but in the sense here. So is melted. So melting period can be generally results in 1 to 10 means here in the starting. Last class also we already discussed this one in the starting. So we have considered some iron scraps or iron pieces. So in the starting, at the time of starting, these iron scraps or iron pieces are trying to melt at the time of start. So on that situations, the electrons that present in this iron scraps are moving. So this will causes the secondary side of the transformer has a more voltage changes that will lead to the flickers in the system. So now one another one another causes induction machine starting, large induction motor starting. You know that large induction motor starting is also called as the voltage sag. And you see this, I may call this as the voltage sag also, but you can call it as a flicker. Then what is the difference between these two, flicker and the voltage sag? So what is the primary difference between these two? Okay, what is the difference between these two? Now see this, what is voltage sag here? The amplitude is less than sorry, in between that amplitude is in between the, what is that amplitude? Just a minute. In between the 1 point, sorry, 0.1 pu to the 0.9 pu at less than 1 minute time in the short duration type of. Okay, so it's nothing but less than 1 minute time, nothing but in you can see this time, the time gap. 1 minute means here 60 seconds, 60. So 1 second is equal to the 1 Hz, or is nothing but 1 Hz is 1 Hz. You can assume it as so 1 second is equal to the 50 cycles. So you can also treat it that one. This is the amplitude range. Then what? Then what is the number of cycles? 0.5 cycles to some 36 cycles, or some nearly 1 minute cycles. So this is the amplitude ranges. We observe this magnitude range 0.1 to the 0.9. But in the flicker range, you can see this time range, time gap range. You can see this. So the time gap range is in the between the 1 to the 10 Hz. At the same time, you can also observe the, so in the voltage fluctuations, our voltage sag will also leads to the interruption. We are unable to identify by the human eye. But flicker, whenever there is a flicker is happened in the system, less than 0.1 pu, so that will maintain up to the 1 to the 10 Hz frequency time. So that human eye is able to identify that one, that we can call it as the flicker. So large index motor starting. So this will also leads to the flickers, but so and as well as voltage sag. So you know that whenever there is a one machine is operating, it is not only producing that one fault. Okay, this index motor is also causes the voltage sags also. So at the same time, it will also causes some flickers. Then out which type of flickers are then what is the type they can run is nothing but here. For suppose we can eliminate these flickers or some voltage dips in the system. We are using some automatic transformers to start the index motors or dual starters, or some auto transformers. So because of using of those devices to start the next motor, that will also leads to the some problem. What is that problem? That you can call it as that will lead to some harmonics. What type of harmonics? And interharmonics. Now see this. So you see this one. We have to assume here one plan. That plan has the nearly 4 motors, or 4 to 5 motors are available in that. Next motors are available in the plan. So this is the this is the US pattern, US system. 120 volts is the normal voltage level. So whenever you have to start the next motor, what will happen if the current is increases, a voltage level is falls. After some time, will go to the normal level. After some, then you can start the another motor. So then you can start the some other motor is like this. Is like this. So you have to reduce this dip, voltage dip or sag. You have to reduce this one. This is the RMS level. You can take and draw in the RMS level. I have to reduce this voltage fluctuations or dip. I can someone call it as a dip, someone call it as sag water. So we are using some starting methods. Some starting methods. to eliminate the this one. Because of this some this type of starting methods and devices. So what will happen? So it can causes the some interharmonics in the system also. So interharmonics, now see this including some interharmonics in the system. This what is this interharmonics? So what is the frequency ranges here? 1 into 50 hertz, 2 into 50 hertz, again 3 and integer multiple of this 50 hertz. So 1 into 50 hertz is a fundamental. So we can treat it as a normal. Other than this, some frequency variation, some harmonics. We can calculate it by using this total harmonic distortion. What is this interharmonics? In between the 50 to 100 or in between the 100 to 120 hertz, we can call it as interharmonics. This will also leads to the some damage in the system. So these are the some sources for producing the flicker. What are the different sources here? A weak load. A weak load in the sense here, a short duration of variation of the loads, we can call it as a weak load. A strong load in the sense nothing but a fixed voltage range, a fixed voltage loads, a constant voltage loads, we can call it as a strong. A weak in the sense here, varying, so rapidly changing loads. Okay, so those we can treat it as the sources. So main source is electric arc furnace as well as the large induction motor starting. So these are the two main reasons. At the same time, another one is also there. So those are the electric arc welding is also there. Welding. You observe that whenever you are going in the outside when welding shop, you see this whenever they are welded to the iron, you observe when they can on that one, you can observe the lights on the shop, they can how that is changes the illumination, that we can, that is the one flicker, that is the one flicker. You can observe that in practically also so many times. So in few days back in my house also I can observe the flicker also because of some heavy rain on that time. I can observe the flicker. Okay, so out of for suppose suppose some another problem. So out of for suppose we have considered the three phases in our house. Out of three phases, only two phases are coming. That means one phase is because of some problem in the system, power system. One phase is open. Remaining two phases are coming into the house. What will happen at that time? So there are some voltage fluctuations occurred in the system on the time. Okay, so for suppose so there are some another examples. There are some is like lifts, apartment lifts. What will happen when you on the lift? Lift you have some synchronous motors. You have them synchronous as synchronous motors. Or what will happen when you on this when you on the lift? When you arm the lift, some lifts are some induction motor. Most of the lifts they can use it as induction motors also. When you arm the lift, what will happen? So high amount. So when they can lift the weight, so on that time heavy load is taken. So that what current is drawn from the circuit. So voltage dips is occurred. Okay, so many reasons for producing this. Then what is the causes? What impact it present on the system? You know that because of this flickers or voltage dips or whatever it may be, mainly the automation industries are facing the main problems, are facing the main problems. Is nothing but PLCs in automation industry. We are using the most of the devices is nothing but the power electronic based. So PLCs, some automation industry, some PLCs, some PI controllers, some PID controllers, some P controllers, some artificial intelligence based microprocessors. All these are based on some electronic devices. Whenever there is a small amount of change in voltage or current to these PLCs or any controlling circuit or any power electronic device, what will happen? You know the characteristics. But so what is the power electronic device? Some different types of power electronic devices are there. What are the power electronic? Some MOSFET, some IGBT. So so many devices are there. Some thyristors, etc. So many devices are there. So a small change in voltage and current will changes the turn on and turn off of this device SCRs, silicon control rectifiers. These devices, reactors. A small amount of change in voltage and current will turn off time and turn on time it changes. That will lead to the huge impact on the automation industries. Or suppose an 100 robots are working in automation industry. What is the use of that robots? That robots are trying to weld the some car. So because of changes in voltage and current, instead of is welding in place one, it welded the place two. What will happen? The car will damages. Or you can take some packing industry. So it packed the 500 grams instead of 500 grams due to this programming logic controllers. It can pack the 600 grams or 300 grams or whatever. Or you can consider this some electronic industry. You have take the so many electrons. You know that lakh millions of circuits are installed at the IC. There is some changes in this voltage and current. What will happen? This is 1 2 3, then 4 5 6. Instead of you can suppose you are placing the first position. Instead of first position, you will place the any another position. The entire board is damages. Nowhere working. So many problems. Power cut is the uh, mainly impact on the automation industries. Okay, so many devices are there to reduce this power quality issues. So many devices, some capacitors, transformers, some online UPSs, some ferro resistance transformers, some trap chain transformers, some LTS, LTCs, and then hybrid UPSs, some reactors, some filters. So many devices are there. We are already discussed all those devices. Now, one of the another main devices is SVCs. One of the another important one devices for to maintain the power quality, a constant power quality, or to maintain the voltage regulation constant. Or here the case we are using it for the flicker, but these SVCs are I can call it as a static wire compensators. So many types are there. So DStatCom, okay, DVR. This is the this is not the static. You can call it as a dynamic voltage regulator. So this is the series connected device. Series connected device. You know that whenever connected series, parallel connected device or shunt connected device is more advanced. This is the shunt connected device. Shunt connected compensator or reactor. Shunt connected. This will though these devices are simply some supplying some voltages, are simply injecting some currents to reduce the power quality issue. Simply, then you can see this how they can some UPFCs or UPQCs or TSC, TCR. So many devices are there. Okay, hundreds of devices are there. Hundreds of technologies are there to mitigate these flags or mitigation in the sense, remember, reduction. Mitigation means a reduction. Okay, mitigation means a reduction to reduce this one. Okay, now we can see this regulations. Okay, now see this SVCs. These are some mitigation techniques we already. So what is one of the mitigation techniques is static wire compensator. Now see this some function of the static wire compensator, how the static wire compensator is working. Now see this. This is the static var compensator. Now see this. This is the static var compensator. Okay. See this. See this static var compensator. It's nothing but this SVC is nothing but a TCR. This is a, some combination of some TCRs. So now see this TCR, this diagram. This so how this SVC is connected to the line. See this. See this. So as I said earlier, while connecting three-phase transformers at a time. So these devices are connected by point we call it as a PCC, where you can connect these devices on load side. And which load side? For suppose we have the source. These are the some feeders. More number of feeders. 1, 2, 3, then 4, then 5 feeders. You can identify that which feeder will get the more problems, more poor quality problems. Then you can identify that problem near to that load conditions. You can add the risk devices. That point you can call it as a point of common coupling, PCC. So in this PCC, how these devices are connected? So through the transformer, through how these devices are connected. So how this device, for suppose I can identify this is the PCC. How this device is connected by using some transformer. You're not directly injected into this one. By using some transformer, you are connected to this device. So this transformer, whenever you are tracking this transformer, the transformer may be of linear transformer, but primary and secondary is constant. Or three-phase transformers, three-phase linear transformers, or three single-phase transformers. Most preferable advantageous case is three single-phase transformers, nothing but single phase and single phase and single phase for three phases. Okay, you know that we already discussed what is the advantage of this one. Whenever you are connecting, so you know that on which phase of the system will get the voltage regulations. Out of this, out of the three phases, you will get only and for suppose an R phase is getting the voltage fluctuations, or Y phase is getting the voltage fluctuations, or B phase will getting the voltage fluctuations. You are not assuming that three phases at a time. You are not estimating that also. Three phases at a time you will getting the voltage fluctuation. Okay, we are not estimating. So three single phase, by using this three single phase transformers, we are connected this type of static var composite. Static var composite nothing but a TCR. You already discussed about that one TCR also. So TCR. Okay, is nothing but some. This is the some combination of is nothing but some source here. Is nothing but. Now see this. Inductor and a capacitor. This is TCR and single line diagram. You can draw the single line diagram. TCR. So this is the combination of inductance and capacitance. Remember, whatever we are discussing, UPFC or DVR or DStatCom, SVC or UPQC, whatever that TCR, TSCs, those all are the compensating devices that simply, remember this point carefully, simply injecting some currents and voltages to the system to correct the power quality problems in the power system. Those devices are the compensators. Some compensators. You can compensate. Remember, you can compensate. It's nothing but you can inject some power. Okay, but what they can do here? It can inject some power. Okay, remember, it can inject. How they can inject? How they can inject some voltage or current into the system? How is it possible? How is it possible? So this is the Vs. Remember, once again see this. So this is PCC. This is the load. So this is the some device, some compensator SVC. You can assume in this case here compensate SVC. So the output voltage is like this. I will get the, so this, what this device is do here, it can compensate this voltage, this level of voltage. You can compensate this level of voltage. You can compensate this voltage, this gap. You can compensate this gap. How to compensate this gap? How to fill this voltage level? For suppose this, how to fill this voltage level? So how to fill this voltage level? So this device is fill this voltage. Then how this device will get the voltage levels? So this device is full of power electronic based here. Remember, this device is full of power electronic based devices. Now see this. Now you can see this power electronics based devices. So why these power electronic devices? It can can convert this some AC into the DC. Most of the cases, some DC into the AC or phases. How to supply, how to store this energy? Whenever it has the energy, then only it can send this some this compensation voltages or current to the system. So all the compensating devices will get the some capacitors, some source, some capacitor source. Someone are using some positive, someone are using some superconducting type of capacitors also. Someone are using some backup capacitors. So many types. So this is also one of the some research topic. Which type of capacitor we are using. So here they can use the capacitors. Why these capacitors? These capacitors are helpful for two ways: to supply the, okay, so to compensate the voltage levels, to the power system. Or second one, we are using some inductance. So combinedly LC, so sometimes it will also treat it as the see this some filter also. It's like this. So without this capacitors, you see this any compensating device, you can see this. Without this capacitance or nothing but you can also call it as some battery. You can use it as a battery. Without any power source, how this SVC are some injecting some voltages are current to maintain the so yes, see this. This is the amount of voltage it can inject. How to inject this one, this voltage? Without any backup, without any power source of this SVC. So definitely any compensating devices, it has some capacitance. Okay. So because again now see this compensating device, we are using this some thyristors. Again this thyristors will also leads to the non-linearities in the system. We are using these thyristors to reduce this non-linearities also using this SVC. But here in this case we are using this SVC to reduce the flickers. So it can inject, remember, it can inject some voltages and current. So this is the, that SVC static VAR compensator. One of the type is TSC. So this is the some TCR device, TCR type. So another one is the TSC. You can see this TSC. You can see this. It has only the capacitor. So it can, what will happen? You can supply some reactive power in the power system to reduces the power voltage. Remember, you can once again you can remember you can consider any type of the device that may be of SVC or TCR, or TSC or DVR or DSTATCOM, UPSC or UV, any compensating device. Without this capacitor is unable to work. So what is the main function of this device? Compensating devices, it can inject some voltage or current to the lines to correct the problems, power quality problems. How to inject this one? How to inject? So by injecting this voltage and current, it must have some source. So that source you can call it as some capacitance. Some more number of sources are available to energy storage sources. More number of different types are there. Okay, so this is the some SVC. You know that what is TCR? The last class we already discussed TCR. So you can simply it can inject simply can inject some voltages into the system to correct the uh, this levels power quality issues. What is the advantage of this thyristors? You know that the battery source are these, but you require the power and AC. So by converting this, we'll require this some sources. Okay, more number of devices are. Then how then the case, how much amount of voltage are currently you injected into the system? For suppose out of 100, for suppose this is the case, this is the case time t, this is voltage, this is 1 pu. So how much gap is there? So for suppose only 0.5 pu to the 0.7 pu is the voltage dip. You know that you can assume this is not only helpful for injecting the voltage, it is also helpful for reducing the voltage swells also and flickers and so many problems. How much amount of voltage and current is injected? You know that how to know that? For suppose you are assuming that manually you are calculating 0.5 to 0.7, but automatically it can inject the voltage and current into the system. How to know that? By using this some control devices, some controlling devices, some PI controllers, some PID controllers, some KP controllers. It can estimate the error. Is nothing but how much voltage drop is present in the system. How much error is there? So how much error is there? So this error is there plus how much error is there? How much capacitance we are given to the line PI control. So in this way they can that error amount it can inject into the line to correct the power quality issues. Okay. Okay. So these are some devices. So these devices is not only used for flickers. These devices are used for the sags, swell cases. Then we also use for the harmonics and power quality improvements and so on. So the static power compensator is not only used to mitigate the flickers, but also used for the power factor improvement also. Okay, so all these things are available in textbooks also. You can see this. Okay, so if you have any doubts, then you can ask. Okay, thank you.